Hello students. In previous video, I discussed about the two types of architecture. One I called the Harvard or another is Princeton architecture. So already I told that in the Princeton architecture, it is also called von Neumann architecture also. There are program memory, data memory and every types of memory must be included in the same memory location. But in the Harvard architecture, every memory have the separate memory space allocated different memory location. So what is the difference? That means in the von Neumann architecture, or sometimes it is called also Princeton architecture, it means all memories must be in same memory location. But in the Harvard architecture, every memory have its own memory location. Maybe data memory, maybe program memory. Say all are in different memory location. So what is the advantage and disadvantage of this two architecture? In Harvard architecture, in Harvard architecture, though this architecture is little bit complicated, less time is needed to access the memory. But in the uh, von Neumann architecture, all are in same memory location, but it is need more time to access the memory because all are in the same memory location. It is need some time to search what memory actually you want to access. Okay, so now we going to see the what type of architectures or what is the types of architectures it looks like in my next slide. Okay, so it is a Princeton or von Neumann architecture. So in this architecture, you can able to see all memory is program memory, variable RAM, stack RAM, all memories must be in same space, same space. Okay, so in this architecture, if processor if processor want to access the memory in that time, processor must be uh, call memory interface unit. After that, data at control anything, any memory, we can able to access it to this unit, through this unit. So this is called von Neumann architecture. So all memories in same space. This is structure. Processor, if processor want to access the memory, it will call memory interface unit. After that, it can access the memory. And instruction decode these instructions. If it's want to give some feedback, it can do. Okay, so this is called Princeton or von Neumann architecture. Let's see Harvard architecture. In this Harvard architecture, now you can able to see program ROM, variable RAM, both are in different space. PC stack also in different space. So all memory location not be in same space. So if I want to access the memory, the processor may able to access the memory also through instruction decoder, also through instruction decoder. After that, it can able to access. But separate memory locations are there. All are separate memory locations are there. Separate location for program memory, separate location for data memory or variable RAM. Anything you can able to tell. Okay. So this is the two architectures are available in the microcontroller industry. So also another two types of as per this is previously as per the processor architecture, we can able to segregate the structure. Now, as per the programming, we can also able to segregate the processor in two types. One is called CISC, one is called RISC. So RISC stands for reduced instruction set computers. Instructions are as bare a minimum as possible to allow user to design their own operation. Means my instructions are very much less, you can say, or bare a minimum as possible to allow user to design their own operation. Means to perform the operation, very less instructions are needed in the RISC instruction sets computer. Now, what is CISC? CISC is called complex instruction set computers. That means the large numbers of instructions, each carrying out a different permutation of the same operation. That means to do the operation, there are different types of instructions. Instructions are available in the CISC computers. That means multiple ways are available to perform one job in the CISC instruction set computers. So as per the architecture, there are two types of architecture is there. One is von Neumann and one is Harvard. As per the programming, also there are two types of computer instruction sets are there. One is CISC and RISC. So previously what I discussed, it is related to hardware. Now it is related to CISC and RISC related to software.